Hello and welcome to our presentation today. This is RONI Ali from B Fuel Company, and this is our first progress presentation for PNGE 418. The outline of our presentation goes as follows. I will start by discussing the work we have done so far by the end of last semester. Then I will talk about the analysis we have done using the decline curve method. And then I will also discuss the production history analysis, moving on to be able to calculate our original oil in place. We have used three methods. The first method that we have used is the material balance method, and the second one is volumetric calculations. The last method that we have used, which is used by statistics, it's Monte Carlo simulation, and I will love to end our presentation by discussing our future plans. So what we have done so far, based on the property maps that we calculated or that we plotted last semester, we chose three new well locations, and for those three new well locations we calculated the pore and fracture pressure. Using the pore and fracture pressure, we also designed our mud window. Moreover, we also started and finished our casing design. We also designed our mud and cement design. Then moving on, we started our drill string design by selecting what type of bit we have. We also finished the drill string design, which was consisted of heavyweight drill pipe, and drill strings. At the end, we finalized our drilling plan by selecting what type of rig that we will use, which is suitable for our case. A decline curve analysis was conducted for the 20 wells that we have a production history for them. For example, we have calculated the amount that we produced, MP, and the numbers that are seen in table are in MSTB. Also, we have tabulated our initial flow rate for the 20 wells. Then we have also forecasted the production for the next 10 years. What will be our production for the next 10 years? Also, the ER10, which is the forecasted production for the next 10 years, is in MSTB. The total cumulative forecasted production for our field is 1,276 MSTB. The figure on the left is showing us the decline curve analysis that we have conducted on well number 45. The violet dots are the predicted flow rates that we obtained, and also the pink dots are representing the actual flow rates versus month. On the right table, we have also tabulated OPC1 and OPC2. OPC1 is representing the decline curve analysis that we have conducted for each separate well and then summed everything together. OPC2 is representing the decline curve analysis that we have done for the whole field together. We have obtained very close numbers for the predicted production, which are shown in ER10. Again, it's in MSTB. And the recovery factor here is also very close for both scenarios. The recovery factor here is actually telling us that most of the production was conducted in the first 2 years, and in the next 10 years, 20% will be recovered. In this slide, we can see the decline curve analysis method that we conducted on the whole field, which we obtained the results and tabulated in the previous slide, which was represented by OPC2. Moving on to the production history analysis, we have decided that we will plot 4 different bubble maps to be able to understand if the previously chosen well locations were actually in the best positions that we chose, or if we need to change it. So we have plotted the initial flow rate. We have also plotted the amount produced, and we have also plotted the pressure and radius of investigation. Even though the equation that we used for the radius of investigation was probably not the correct equation, but the behavior of all bubble maps are showing a similar activity. So to be in the safe side, we assume that okay, we can move on with this equation, even though it's not the true equation that we need to use. After we have created the bubble maps, we have realized that the previously chosen well locations were not the best or the most optimum well locations that we need, that we need to drill in. So from last semester, we have used the reservoir quality index map as the best indicator of where the new well locations that we need to choose. Combining the reservoir quality index map and the previously made bubble maps, we have decided 3 new well locations that are shown in the right figure. Also, that we decided that the initial flow rate for any of these wells should be around 130 to 140 STB per day, because the closed well locations around these 3 well locations, the initial flow rate is in that range. In this slide, a tornado chart can be seen. Basically, we have decided to conduct a very simple sensitivity analysis using 3 parameters: the water saturation and the thickness of our reservoir alongside our porosity. Our highest hitter is the thickness of our reservoir. We can see that the thickness of with increasing the thickness of our reservoir, the amount of original oil in place positively increases. Same goes with porosity, but with less amount of original oil in place. But when we increase, we can see that when we increase the water saturation, we see that this affects negatively on our original oil in place. We have decided that our drive mechanism for our reservoir, for our case, is the solution gas drive. Thus, the tabulated information that we can see are obtained using the solution gas drive mechanism. Also, we have decided that we need to assume our water influx. We've used the Havlana and Ode method to be able to find our water influx. The Havlana and Ode method is basically the trial and error method. Also, in the 2nd, 3rd, and 4th month, alongside the 22nd and the 23rd month, we have not included the calculations in the upcoming slide to be able to predict the water influx because we were lacking the pressure values in these months. Since we have decided that we need to apply the trial and error method, which was Havlana and Ode method, basically we were changing the water influx alongside the other parameters until we got our slope as 1. The closest that we were able to get is 1.0021. The Y intersection here shows us the amount of original oil in place, which was 26 mmSTB, and the recovery factor for our case was 3.88%. Another method that we used to estimate the original oil in place was the Monte Carlo simulation. We use statistics and random number generators to be able to conduct this simulation. The table on the right shows us the P10 and P50 and P90 amounts that are in mmSTB. The difference between Monte Carlo simulation values and the Havlana and Ode values is coming because most probably we have some slight error in the area calculations that will be adjusted in the future. CMG is a very powerful tool in our industry. It is used for various aspects, but for the beginning we started just to be able to visualize what kind of topography, what kind of geographical structures do we have. In the both pictures that we can see here, they are both representing the top view of our reservoir. To end my presentation today, I want to discuss the future plans that we have as a company. The first thing that we will do is the reservoir model history match. After finding the reservoir model history match, we will start the production and field development design. And at the end, we will do the economical and sensitivity analysis based on different aspects. Thank you for listening to us, and I will be glad to answer any questions that you have.